Right, welcome to today's video. This is Mathswatch 5. The questions that were submitted last time will be put into a Mathswatch 6 video. I got a few more questions yesterday or the day before, but I'm going to put those into a separate video. This video will just be the questions from about 6 or 7 days ago. But yeah, let's get into those questions now. The diagram shows a rectangle, 5 centimeters by 1 centimeters. 4 of those rectangles are put together as shown. Calculate the shaded area. Let's get the pen out. Okay, so let's work out the lengths of the width and the height, or just the height and the length, the width and the length, however you want to label them. So we're going to call this the length, we're going to call this the height. Now this is just the length of one of our rectangles. One of our rectangles is 5 centimeters. Okay, perfect. Awesome. Right, okay, now we want the height. So the height we can use by intuition. So we know that this here is 1 centimeter. We know that this here is 1 centimeter because it's the height of this rectangle, and then vice versa. We know that this is 5 centimeters as it is the length of one of these rectangles. Here we've just turned it round. Instead of it being long, it's now tall. We've just turned it round to become that, and we put it on its side, so this is just going to be 5. So we have 1 centimeter here, we have an unknown length, and we have 1 centimeter, and that gets our 5. So we have 1 centimeter plus our unknown length plus another 1 centimeter, and that gets our 5 centimeters. And now we can just solve that. 1 plus 1 is 2. 2 plus our unknown equals 5. Our unknown is clearly 3. So we're going to solve that for 3. So we now know that our height is 3 centimeters. And to find the area, we just multiply these two numbers together. 5 times 3 equals 15. And remember, and if it's not put in the, so the answer will be in a little box. And sometimes it gives the units afterwards, sometimes it doesn't. If it doesn't, remember that the units are centimeter squared because it's an area. Okay, so our answer is going to be 15 centimeters squared. Let's go on to the next question. In a diagram shows a bunch of things. Work out the values of A and B. Right, okay, so it says the PQRS is a rectangle. So PQRS is a rectangle, and then it says that the area of PQRS is 45. So let's work out the area of PQRS in terms of the labels. So the area of a rectangle is the width times the length, or the height. It's the width times the length, or whatever. It's the, in this case, the width times the height. So the width is this, and we know that this and this and this are all the same because rectangles have paralleling equal opposing lengths. So we have A as our width multiplied by our length, which is 7, plus B. So we have 7 plus B. When we expand that, we get 7A, because we've done 7 times A, and then we have to do AB. 7A plus AB. And we can equate this to 45 because the area of the PQRS is 45. It says so here. So 45. Then it says the area of PXYS, so this smaller rectangle, is 10. So sorry, I've written that wrong. PXYS, the area equals 10. And then if we use the question, again it says that xy is parallel to PS, and then we've already said by intuition that it's parallel to PR, so we can call this length here A. So the width times the height equals A multiplied by the height, which for this small rectangle is just B. So A times B. So we have 10 equals AB. Now we can't solve for A or B using this. Oh, sorry about that. There we go. Right, so we can't solve using A or... that's what I did, okay. But what we can do is this AB here matches to this AB here. We can sub in our value of AB. So if we go over here, we can say that 45 equals 7A plus AB. AB equals 10. So we can just sub that in, and now we can solve for A. So we take 10 off both sides. 35 equals 7A. And now we just solve for A. Divide both sides by 7. And then A equals 5. And now we can just use our value of A to solve for B. So 10 equals AB. Let's sub in A. At 10 equals 5B. Therefore B equals 2. And that's your answer. So A equals 5 centimeters. B equals 2 centimeters. And that's our answer. So let's get on to the next question. A cross-shaped pattern is made by arranging 4 identical rectangles around the sides of a square as shown in the diagram. The area of the square is 64. The area of the rectangle is 1.5 times the area of the square. Find the perimeter of the cross-shaped pattern. Show your working and state the units of your answers. So this one does want you to state the units of your answers. Sorry, it's just a lot of talking. Sometimes I need a bit of a drink. Right. So let's get into it. So we're looking for the perimeter. We know if the square, so I'm guessing when it says square, it means this square here is 64. So the area of the square equals 64. How do you find the area of a square? Well, you just do the width times the width, the length times the length, or the height times the height, whichever level you want to use. So it's basically just a length multiplied by the same length, so that we have a length squared equals 64. That's supposed to be an L. So we just find the square root. Let's put a little thing over that. So the length squared, the square root of the length squared is just the length, and the square root of 64. This is something that you should have a good idea of. This is 8. So we know that our little length here is 8, and because of the rules of rectangles, we can also say that this length here is 8, and so is this length here, so is this length here, so is this length there. Because we're trying to work out the perimeter of the cross-shaped pattern, and by putting in our little 8s, we have found a third of the length that we're looking for. So we've got 8, 16, 24, 32. Now we want this length here. So let's use the clues that the question gives us. So it says the area of each rectangle is 1.5 times the area of the square. So 1.5 or 3, 2 as a fraction, times the area of the square. The area of the square is 64. And this here is the area of our rectangle. So let's do a bit of solving. Let's get rid of that 2. Let's replace this with 32 because half of 64 is 32. Now it's just 3 times 32, which equals 96. So the area of our rectangle is 96. How do you find the area of a rectangle? Well, it's length times height, and this equals 96. We know the length, or we know the height. In this case, we know this length here. So when we draw our rectangle, we know that this is 8, and we don't know this. But now we have our area, we can solve for the length. I'm going to call it, it's a bit confusing. I've got L as 8 here, isn't it? Let's just put some in our value. So 8 times our unknown equals 96. Now you can solve this using long division. So if we do an 8 and then we do 96, how many 8s go into 9? 1, remainder 1. How many 8s go into 16? 2. So our question mark equals 12. So we now have 12, 12, 12, 12, 12, 12, 12, and 12. We have 8 lengths. So when you count the so when we draw our cross, it's not a very good cross, we have 8 of these rectangular lengths, and we have 4 of our square lengths. We count them all out. In fact, I'm going to do this in different colours just to make it a bit easier to distinguish. So we have 1, 2, 3, 4. Those are our lengths that we've gotten from our square. And then we also have the rectangle, the long rectangle lengths, that we have them here. So we have 8 lots of 12, and we have 4 lots of 8. 8 12s, I mean, we could work it out, or we could just say, well, we've just done 96 divided by 8 to get to 12, so let's just go backwards and say that that equals 96. Plus 8 4s, 8 4s are 32. We add this together, we get 128. And because it says state the unit of your answers, a perimeter is a length. So your length is going to be in centimetres, not centimetres squared, because that's an area. A perimeter is a length. Let's get into the next question. There are 84 members of a tennis club. Okay, so when we're doing this, what number's going to put in straight away? 84 members, so we can put an 84 right there. It says 48 of the members are male. Okay, so we've ticked this bit off. 48 of the members are male, so 48 members are male. We can then work out how many are female by doing subtraction. 84 minus 48. 4 minus 8, we can't do that. We pinch 1 off this 8, becomes a 7. 14 minus 8, that is 6. 7 minus 4 is 3. So we can put a 36 here. And now let's get on the next one. Half of the female members and a quarter of the male members are under 30. So what's half of 36? So 2, 36. How many 2's go into 3? 1 remainder 1. How many 2's go into 16? 8. So the female members under 30. So we've got 18. And we can also just put 18 here, because if half is under, half is going to be over. Quarter of the male members, what's a quarter of 48? How many 4's go into 4? 1. How many 4's go into 8? 2. So 12. And then we can put a little 36 there. Oh, I've put that in the wrong box. Yes, because it says under the quarter of the members are under 30. So quarter is our 12, and over 30 is 48 minus 12, which is 36. And that's this question done. There are 90 pupils in a primary school, so the first thing we do is we put the 90 there. We tick this one off. Exactly half of the members are male, half of 90. So let's work out half of 90. How many 2's go into 9? 2, 4, 6, 8, 10. We go back 1, 4. Remainder 1. How many 4s go into 10? 5. Right, okay, so we put our 45 here. We put our 45 here. Now it says a third of them attend homework club. A third of the females, sorry, attend homework club. What's a third of 45? So we do 3, 45. How many 3s go to 4? 1 remainder 1. How many 3s go to 15? 5. Attend homework club, so 15. Now, notice that it says a third of the females and 2/3 of the males. A third plus 2/3 is 1, i.e. our original number. So, however many attend homework club for the females, don't attend homework club for the men. So we can put a little 15 there. Attend homework club, so 45 minus 15, because essentially we're doing 1 minus a third, and that gives us 2/3. That's not very good, 3/3. So we subtract this. 5 minus 5 is 0, 4 minus 1 is 3. So we can put a 30 here, and we can put a 30 here. And that's this question done. 56 boys and 36 girls attend a zoo. Okay, so let's add those together to find the total. 56, 34, 6 plus 4 is 10, 0 with 1 carried, 5 plus 3 is 8, plus 1 is 9. So you can put 90 here altogether. 46 of the children have a voucher, so voucher, yes. 46 we can put there, and by subtraction we can work out how many don't have a voucher. 90 minus 46. Pinch 1 off the 9, that becomes an 8 with a 1. 10 minus 6 is 4, 8 minus 4 is 4. So I can put 44 here. And now it says 3 times as many boys as girls do not have a voucher. So, if we let girls equal some arbitrary letter, some algebra, we're going to let them equal G, because, you know, G is the first letter in the word girls. Then it says that boys, well, there's 3 times as many boys as girls, so boys we can equal to B, but this also equals 3 lots of girls, or 3G. So if we look at our no vouchers, 3 times as many boys as girls don't have vouchers, so we can say that G plus B equals not having a voucher. How many don't have a voucher? Well, we found that out, it's 44. We can sub in our value of B as 3G, so G plus 3G is 44, or 4G is 44, therefore G equals 11. So we can say that 11 girls don't have a voucher, and 3G, which is going to be 3 times 11, 33. Now we have to use our original line, this line here, to work out the last bit, because it says 56 boys attend the zoo. So if 56 is the total, and 33 don't have a voucher, then it means some unknown value does have a voucher. We take 33 off both sides. 6 minus 3 is 3, 5 minus 3 is 2. So 23 boys do have a voucher, and then we can just do 46 minus 23 to get the last bit. So 46 minus 23, 6 minus 3 is 3, 4 minus 2 is 2, so 23 girls and 23 boys do have a voucher, 33 boys and 11 girls don't have a voucher. That's that question done. Let's go on the next one. Lois has one of the following colours, a felt tip pen in her pencil case. She pulls up 2 at random. How many different combinations of pairs of colours are there? I would assume that this question does not rely on order. If it relies on order, then you'd say, well, red and blue, but also blue and red. So what we're going to do, we're going to assume that it doesn't rely on order, and it's just each one. So we're going to say let's assume, oh, there's the pen. Let's assume that she pulls out red at first. How many combinations are there now? So we've got red and blue, we've got red and yellow, we've got red and green, we've got red and purple. Okay, so that's all the red ones done. Red's done. Now let's assume she pulls out blue at first. Now we don't go backwards because we've already done red and blue. We go forwards. If she pulls blue out first, she could have blue and yellow. She could have blue and green. She could have blue and purple. So we had 4 for the reds, and 3 for the blues. Let's say she pulls out yellow at first. Again, we don't go backwards, we only go forwards because we've already done blue and yellow, we've already done red and yellow. We go forwards. Yellow and green is 1. Yellow and purple is 1. So for yellow we have 2. For green and purple, for green, sorry, we don't go backwards, we only go forwards. Green and purple, we have 1. Now for purple, we don't go backwards, we only go forwards. There are none forwards, so we say 0. So we say 4 plus 3 plus 2 plus 1 is our answer, and that answer is 10. One combination is red and blue. Write down all the possible combinations. Your answer must look like this. Okay, I'm going to pause it because we've already gone through all the different combinations. I'm going to pause it and write them out because it will be quite monotonous to watch me write them all out. And I'll come back to you once I've done it all and I'll explain what I've put. Back in a second. Okay, so I have written out all the answers, and like I did when I was going through the different combinations, I did all the reds first. So I did the reds I've put here, then I did all the blues, then I did all the yellows, and then I did the greens. Not to say that only the reds are there and only blues, because a blue appears in the reds, a yellow appears in the blues, a green appears in the etc. But all the ones where we've selected each colour first. So the 4 red ones we did first, red, blue, red, yellow, red, green, red, purple. Then we did the 3 blues, blue, yellow, blue, green, blue, purple. So often B, Y for blue, yellow, B, G for blue, green, B, P for blue, purple, Y, G for yellow, green, Y, P for yellow, purple, and then G, P for green, purple. I'm assuming it wants the answers like that. Anyway, let's get to the next question. How many questions are left, by the way? Oh, quite a few. Okay, so 1, 2, 3, 4, 5. Okay, so 5 questions left, including this one. Hector wants to make a sandwich using a roll or a baguette and ham or turkey and pickle or cheese. Write down all the possible combinations Hector can make. One of them been done for you. Roll, ham, pickle. So you pick one, then you pick the next one, and then you see what options are left. So first thing he's done, he's picked a roll, then he's gone down, and he's picked a ham, then he's gone down, and because we're on our last one, what's left? Well, there's pickle. You can have roll, ham, and pickle, or roll, ham, or cheese. So we do roll, ham, cheese. These are all the roll, ham answers. So next we go up, and we go right here. So now we have roll turkey, and again we can have pickle or we can have cheese. So we have roll turkey, pickle, or roll turkey, cheese. Now we've done all the roll hams and all the roll turkeys. Now, because when we were finished with the pickle and cheese, we went up back to ham, we went up to roll, and then we went here. Now we do the same thing, but here we go up. We go here, we go to the baguettes. So now we have baguettes, and we can have baguette ham, and then we go down, baguette ham pickle, or baguette ham cheese. So we have baguette ham pickle, or baguette ham cheese. And again, we do the same thing. We go up from the ham, so we go back to the baguette, and now we go to turkey. So baguette turkey, pickle, or baguette turkey cheese. And that's our answer. We have 8. We have 1, 2, 3, 4, 5, 6, 7, 8. What fraction of the possible types of sandwich have turkey and cheese? So we're looking for a T and a C in the same one. So TC, no. TC, no. TC, no. TC, yes. TC, no. TC, no. TC, no. TC, yes. So we have 2 out of our 8, or we simplify it to be a quarter. So 1 quarter. And that's our answer for this question. Let's go to the next one. A fair spinner has equal 1, 2, 3, 4. A fair spinner has equal 5, 6, 7, 8. Work out the probability that a total of 10 or more is made. Okay, so if we're gonna draw one of these things here, and you'll see what I'm doing in a second. I've not done it very neatly, but as long as you have the boxes, that's the important thing. So we're going to have spinner A at the top, spinner B at the side. We're looking to add the numbers together. So we have 1, 2, 3, and 4, and then we have 5, 6, 7, and 8. And each one of these boxes here represents represents an outcome, and then we add our outcome together. So we have all these boxes. So we could have 1 and 5. We could have 1 and 7. We could have 3 and 7. We could have 4 and 6. And we're looking to add them all up and see how many of them get 10 or more. So 1 and 5, that's 6. 2 and 5, that's 7. And then it just goes up 8 and 9. 1 and 6 is 7, 1 and 7 is 8, 1 and 8 is 9. And then you just go through all of these doing the sum. So 8, 9, 10, 9, 10, 11, 10, 11, 12. Okay, I want to change the colour for this bit, just so we can distinguish. I'm going to go to dark red. Okay, now it says we're looking for the probability that the total is 10 or more. So we're looking for numbers on here that are 10 or more. So 10 is 10 or more. We have 3 10s. We have 2 11s. And we have 1 12. 3 plus 2 plus 1 is 6. We have 6 outcomes that are 10 or more. So 6 is our top fraction over total number of outcomes. Total number of outcomes is 16. We have a box of 4 by 4. That adds to 16. We can simplify this to 3 over 8. Here is your answer, 3 over 8. Here is some information about a group of 20 children. A child is chosen at random from the group. What is the probability that the chosen child is a girl? So, how many girls are there? There are 3 left-handed girls and 5 right-handed girls. 3 plus 5 is 8. 8 over 20, because 20 is the total number of children. Or 4 over 10, or 2 over 5. Assume that they want the most simplified version of the fraction, just to be on the safe side. Because normally it will, in an exam especially, it'll say, oh, write this answer in the most simplified form. So our fraction is 2 over 5. Right, what is the probability that the chosen child is a left-handed boy? So how many boys are left-handed? We see where the box meets. We get our number 4. 4 over our 20, which is the same as 2 over 10, or 1 over 5. And our answer for that is 1 over 5. So we have our 2 answers. So for A, we have 2 over 5, and for B, we have 1 over 5. These cards are put into a bag, numbers from 1 to 12. A card is chosen at random. What is the probability of choosing a card with the number 8? How many cards have the number 8 on them? Well, it's only the one, it's just the number 8. So we do our fraction, we do our selected outcome over the total number of outcomes. We have 1 because there's 1 8 over 12 because there are 12 cards. Is this the last question? No, we got one more for this. What is the probability of choosing a card that has a 1 digit on it? Okay, so if we go through our cards, how many of them have the digit 1 on them? So we have, this has a 1 digit. And we go through. This has a 1 digit because there's a 1 and a 0. This has a 1 digit because it's got a 1 and a 1. This has a 1 digit because it has a 1 and a 2. So we're looking for these number 1s. So I'm just selecting or showing all these number ones. So how many cards have a digit 1 on them? We've selected 4 cards. 1, 2, 3, 4. So we have 4 over 12, or 2 over 6, or 1 over 3. What is the probability of choosing a card that does not have a digit 1 on it? Well, we just subtract our answer from 1, because these two outcomes are what is described as mutually exclusive. What mutually exclusive means is that it's either one or the other. It can't be both. It has to be either yes or no. It has to be A or B. Mutually exclusive. It can't have a digit 1 and not have a digit 1 on it. It's mutually exclusive. It's either one or the other. And in our case, our one or the other, when we add them together, becomes to 1, because the probability of 1 means that it has to happen. It has to either have a digit 1 or not have a digit 1 on it. So we have 1/3, which is the probability of having a digit 1, plus our unknown, which is not having a digit 1 on it, equals 1. And that is just 2/3. You can also do this by just counting the number of digits that counting the number of cards that don't have a 1 digit, and you'll count 8. You'll count these 8 here, and then you'll just do 8 over 12, simplify to 4 over 6, simplify to 2 over 3. Okay, so we've got one more question. There are only blue... I had this problem the other day. There are only blue cubes, yellow cubes, and green cubes in a bag. There are 2 times as many blue cubes as yellow cubes, and 7 times as many green cubes as blue cubes. Billy takes a cube from the bag. What is the probability he takes a yellow cube? So, if we say that there is, if we let y be the number of yellow cubes, so be the number of yellow cubes. It looks like I put I've absolutely messed that up. So we're just going to say, let the number of yellow cubes equal y. Alright, so y equals y. Y is equal to itself, it equals the yellow number of cubes. There are 2 times as many blue cubes as yellow cubes. So blue equals blue, but we know that blue is twice as many as yellow, so we put 2y down. Okay, now it says 7 times as many green cubes as blue cubes. So green equals itself. It also equals 7 blue. Blue equals 2y. So we can equate it to 7 lots of 2y, which equals 14y. Now we add them all up. So we have, because we're looking for the total number, we want the yellows over the total number. So y plus 2y plus 14y, and that gives us 17y. The total number of cubes are 17y, or the total number of cubes is 17 times the number of yellow cubes. So what is the probability that it takes a yellow cube? So the number of yellow cubes is y over the total number of cubes, which we've just said is 17y. Well, now we have a y on the top and the y on the bottom. We can cross that out and simplify. So we now have 1 over 17. And that's our answer. Our answer is 1 over 17. Okay, I shall do another video tomorrow, which will be I shall try and finish off the homework videos and do the latest number. I should try and do the more recent Mathswatch questions that have been submitted to me, and I shall try and do the paper 2 for June 2017, which is a calculated question. So anyway, thank you for watching. I hope this was helpful, and see you in the next video. Goodbye.